Hi guys, so today we'll be taking another question on vectorial form of a Coulomb's law. So the question says the magnitude of force AB and force CA are the same in part A. However, the direction of the force of charge C on charge A is different. You now say that force now FCA is plus 3.37125 Newton directed to the right as shown in the diagram below. So this is the diagram. This is 3 microcoulomb, this is 5 microcoulomb, and this is plus 3 microcoulomb. This is charge C, this is charge A, and this is charge B. Now, before I proceed, welcome to Concept Mastering, and please, after watching this video or before you watch this video finish, please click on the like button, comment, subscribe for more videos. Now, but before you watch this video, there's a question I actually sent before. There's a previous video I've sent in my previous class, a question similar to this. This is the second part, the B part of it. This is the B part. So I would suggest you, before watching this video, go and watch the previous one first before this one, so that you're going to understand what I'm talking. Now, in the B part here, they're telling us that the direction of the force have changed. There's a different changes. And what are the changes? Now, the changes is that the charges are now in different position. The charges are now in different position. Before, the charge A was here, and charge B was at the center, and charge C was here. But now, the charge A is at the center, the charge C is at the right, and the charge B is at the left. So that is all these changes now. And they're still telling us to find the net force or the net charge on force A. Still, they are still telling us to find the net charge on force A. Now, we are given to find this net charge on force A, it will be our F arrow A is equals to the force on AB plus the force on AC. Now remember that our distance from A to B, there is our arrow 1 is actually equals to 12 centimeter. And when we convert this to meter, you're going to have our arrow 1 will be 0.12 meters. Our arrow 2, we have it as 20 centimeter. And when we convert this to meter, we have arrow 2 now give us 0.20 meters. Now, our charge A is actually equals to minus 5 times 10 raised to power minus 6 Coulomb. Our charge B is actually equals to minus 3 times 10 raised to power minus 6 Coulomb. And our charge C is actually equals to plus 3 times 10 raised to power minus 6 Coulomb. So now we proceed. Now the very first we are going to find, let's find the force on A and B. The force on A and B. Now, force AB will be our K times charge A and charge B all over the magnitude of AB all squared times our unit vector AB. Yes. So now, I will tell you guys, the first thing is to find your unit vector. And your unit vector is your position vector divided by your magnitude. So let's first find our position vector. Our position vector AB will be the position of A minus the position of B. Now, the position of A, our A is always our origin, and you always take it as 0. Yes, A here is always our origin and we always take it our 0. Then minus, let's find the distance from A to B. Now from this very diagram here, we realize that if we want to find the distance from A to B, you are actually going from our right to our left. We are going to our left. We are going to our left. And in Cartesian coordinates, if you are going to the left, it's actually to the negative side. It's actually to the negative side. Yeah. In Cartesian coordinates, we are going to the left, we are actually going to the negative side. Therefore, we are going to have minus. What's the distance of R1 here? Our distance of R1 is 0.12 meters. Minus 0.12 meters I. Exactly. Now we proceed. So now, therefore, the position vector will now give us minus will give us plus. That means we are going to have 0.12 meters I. 0.12 meters I. Now the next thing is to find is the magnitude. The magnitude, yeah. Which is actually the magnitude of the position vector is actually 0.12 meters all squared, then the square root. Therefore, the magnitude will give us 0.12 meters. If you press this in the calculator, I've told you guys, when you see square roots and this thing, when you see square roots and square, they just cancel each other, and you go to get this. I've said it in my previous video. You can still go there and watch it again. So you have 0.12 meters. Now is to find our unit vector. Our unit vector AB. Our unit vector AB will be equal to our position vector. We have our position vector. We have 0.12 meters I. What do we have as a magnitude? We have 0.12 meters. Now this will cancel this. We are left with I. Therefore, our position vector is actually I. Our unit vector rather is actually I. Now, let's plug in all our values here now. Therefore, let's find the force of AB now. The force of AB will be equals to K, which is constant, which is 9 times 10 raised to power minus, 9 times 10 raised to power 9, brackets. What is our charge A? Our charge A is actually minus 5 times 10 raised to power minus 6. What is our charge B? It's actually minus 3. That is minus 3 times 10 raised to power minus 6 divided by our magnitude. What do we got as a magnitude? We got 0.12 meters. 0.12 meters. Remember, is squared times our unit vector. What do you got as a unit vector? We got I as a unit vector. Now, when you press this on your calculator, the numerator divided by the denominator, what we are going to have, you have our force AB will now give us 9.37 Newton I. That's what you're going to have. So the next thing is, let's find the force of AC now. Let's find the force of AC. Let's find the force of AC now. So to find it, this is what we are using. We are going to still use our force AC. We'll give you K, Q1 and Q2. So QA and QC. all of our magnitude of A and C, the position vector, the magnitude, divided by the magnitude all squared times our unit vector, AC. Now, the first I will say you find your unit vector, and your unit vector is a position vector divided by the magnitude of the position vector. So let's find the position vector. The position vector of AC is actually the position of A minus the position of C. What's the position of A? I always tell you A is always our origin because this is our starting point, is 0, minus what's the position of C? In this diagram here now, watch, if I want to check the distance from A to C, if you notice, you are actually going to our right. You are going to our right, and the Cartesian coordinate when you are going to your right is actually to the positive side, of the x-axis. And you see that our arrow to the distance of our arrow to here is actually 0.20 meters. 0.20 meters. So that will give us plus 0.02. Sorry, this is 0.20 meters. 0.20 meters. Meters I. Minus times plus is going to give you minus. Therefore, the position vector of AC will give us minus 0.20 meters I. Now let's find the magnitude of the position vector, which is actually the square root of our position vector, which is our AC, the square root of this, that is actually minus 0.20 meters I, all squared, then square roots. If you put this in your calculator, you still get this figure back. I've said it in my previous class and I explained over and over again. So our position vector will now give us 0.20 meters. So you don't include your I, don't include I in your position vector. In your magnitude, don't include this I. It will be 0.0 meters. Exactly. Yeah, 0.0 meters. Now let's find the unit vector. Our unit vector AC is actually our position vector. What do we got our position vector? We got minus 0.20 meters I, minus 0.20 meters I. And what do we got as a magnitude? We got 0.20 meters. Our unit vector is always our position vector divided by our magnitude. Our position vector divided by our magnitude. So that's it. Now, let me just write it. Position vector is magnitude. Magnitude of the position vector. So that is it actually. This is your position vector and this is magnitude of the position vector. Now this will cancel this. What are we left with? That means our unit vector AC, which actually equals to minus I. Now let's plug in our values. Let's find the force of AC now. The force of AC, the force charge on AC will be, what is our K? K is constant, which is actually 9 times 10 raised to power 9, bracket. What is the charge of A? Charge of A is actually minus 5 times 10 raised to power minus 6 Coulomb. What is the charge of C? the charge of C is actually minus, no, it's not minus, it's actually plus. Charge of C is actually plus 3 times 10 raised to the power minus 6 coulomb. Yeah. Divided by our magnitude. Divided by our magnitude. What do we got as a magnitude? This is our magnitude. We got 0.20 meters. 0.20 meters all squared. All squared. All squared. Times our unit vector. What do we got as our unit vector? This is our unit vector. We got minus I. So times minus I. Now, when you multiply this on your calculator, the numerator, and divide it by your denominator, what you're going to get is, you will get your first charge on AC will give you minus 3.375 Newton times minus I, this times minus I. So therefore your first charge on AC, minus times minus will give you plus. So that's why you're going to have 3.375 Newton I. Exactly. Now, let's now find the net force charge on A now. Which is equal to the first charge on AB plus the first charge on AC. And that will give us, what do we got as our AB in the first one? We got 9.37 Newton I equals to brackets 9.375 Newton I. And what do we got as our AC here? First AC, we got 3.375 Newton I. That gives us plus 3.375 Newton I. So when you plus this together, you are going to have, therefore the resultant force, or the first charge on A will be 12.75 Newton I. 12.75 Newton I. So that's actually the answer to the question. And now, this thing means that this is the force charge on A due to other forces. It means that the force charge acting on force A due to other forces is 12.75, and it's acting along the positive axis. It's acting along the positive x-axis. It's acting along the positive x-axis. Thank you very much for watching my videos. Please comment, click on the like button and share. See you again next time.